This is the first video on chapter 37 on power series. There's going to be two videos for this chapter. In the first video, what I want to do is I want to give you a very brief outline of definition 224 through fact 230. You have your notes in front of you, so I'm assuming that you're studying them, but I want to give you a brief explanation of what is in those notes. So first of all, a power series is we have the sum n equals 0 to infinity of Cn x minus a to the n. The Cn's are all real numbers, a is a real number, x is our variable. When we write a power series, here's the interesting thing in Theorem 27. One of three things will happen. The first is that the series will converge if and only if x is equal to a. It will always converge at a because x minus a is 0, and so when x is equal to a, you just have the series is constantly 0. That always converges. It might be the case that that's the only place it converges. The second thing that can happen is the other extreme. It can converge everywhere. So in other words, it doesn't matter what your x is, that no matter what number you substitute for x, the series converges. That is another thing that can happen. And then there's a third thing that can happen. There's a positive number r where your series is absolutely convergent whenever x is in this open interval a minus r to a plus r. And then it will diverge outside the closed interval a minus r to a plus r. Now, what this doesn't tell us is what actually happens at the endpoints. So if this is our case right here, we know that our series is absolutely convergent on this open interval. It's going to be divergent outside the closed interval. So on this part here where we have the d, it will diverge there. What it does at the actual endpoints, I have question marks here. That depends on your particular power series. So if we have case 3, if that is the case for a particular power series, then generally what we have to do is check the endpoints separately. Now, we have some terminology that goes along with these cases. In the first case, if it converges only at a, we say the interval of convergence is singleton a, so it's a set that just contains a. The radius of convergence is 0. We think of the length of a single point as being 0. In the second case, the other extreme, the radius of convergence is the entire real line. The radius of convergence is infinity. We think of the real line as having infinite length. In the third case, the interval of convergence is one of four things. It's either the open interval, where we know that it converges absolutely. This might be the only place it converges. The interval of convergence might include the left endpoint, but not the right endpoint. The interval of convergence might include the right endpoint, but not the left endpoint. Or the interval of convergence might include both endpoints. So one of these four things will happen if we have case 3 from Theorem 227. This is Theorem 227. And in this third case, the radius of convergence is always r. So the length of any one of these intervals is going to be r. So this concludes the video of part 1 of chapter 37, and I will do part 2 where we just look at the examples of power series.